This conference will now be recorded.
Hello. Okay. Radhakrishna, this same link, can you share to the Shiva? Actually, Shiva, he is having the one student. And can you share this link to the Shiva and inform that the class is already started? Like, just inform to Shiva. Okay. Okay, guys. So Paul, actually, for Python, for execution of some kind of statements for Python programming language, I'm using the software is Anaconda. So I'm just opening this particular Anaconda navigator in my laptop. If that software is not there with you, then we can just go and download from the internet and try to be install it. Okay. So once if your installation is done, if you try to open Anaconda, it will open in such a way. Once it is opened, then what I can do, I just launch this particular Jupyter notebook. If I launch this one, it is selecting any one of the web browser. So, and I can navigate where my folders or where my files are available. So in the desktop, I already saving every file in one specific folder. The name of the folder is ADS201. And with that one, I'm explaining about Python programming language. As I know, you have some basic knowledge on Python basics. Okay, for this particular session, I'm talking about set data type. So, Paul, do you have any knowledge on the set data type?
I'm not sure what your question is. So you mean set and data types? Yes.
Yes. What do you know about set? Set is one of the data type, which
It's a
is
sequence. Sorry.
absolutely correct. It's a sequential data type. So sequential data type means, so which is holding the multiple data elements in a curly braces, right? So within the curly braces, if we are holding some kind of multiple elements, that we are calling it same set data type or sequential data type. For example, I have a variable, and with this particular variable, and I'm holding some kind of group of elements in a curly braces. It may be integer data, it may be float data, it may be complex data, okay, it may be string data. So like that, even you can hold the string as well. So this is the way we are holding dissimilar data types, and it may holding the multiple elements. Okay, dissimilar or multiple elements we are holding inside of the curly braces. That data type we are calling it same set data type. If I want to know that, just we can use the type of a, which is returns the set. Is it clear? In the meanwhile, what I would like to do now, I want to print this particular data, what data which is there inside of it. See here, when I try to printing the data is what data is there inside of the A, and which is having the what data we are holding inside of it, that data only there. But try to see here, the first element, it wasn't somewhere else. So I hold the second element is 4.5, it was there in third position. I hold the third position data, it was in first position. I have a data in the fourth position, the same data which is there in a second position. Okay, and I have the data SOC, which is actually last position, but unfortunately it was in a fourth position, right? So what you understood from this particular example? See, yet the data is not in order, not in order. Okay, so which means that the first element may becomes to the third element may becomes to the first element or second element. We cannot estimate, we cannot say that why the data is holding in the first position also. Okay, there is no specific order, there is no specific reason how the data is holding inside of the curly braces. So this kind of thing we are calling it say unordered data type. So set, you can say that it's a unordered data type. When which is the unordered data type, which means that we can't access the data, we can't access the data with indexing. For example, how we are accessing the data from the string, list and tuple. In the same way, we can try to access the data, okay, from the set. So which is not support. It won't be support. For example, a of 0. So here, which is we are getting the error is set object is not subscriptable. Okay, scriptable, which means that which is not following the proper order. That's the reason we got an output this kind of type error. So even indexing is not working in the sense slicing and dicing also it won't be work. Data accessing is not possible in case of set and in case of set. So Paul, are you following my point?
Yes, I am.
We can hold the multiple data elements, so that we are calling it a sequential data type. And over here, the data which can be holding in a dissimilar format or dissimilar order, which is not following the proper order, so that we are calling it unordered data type. And if the data, if it is following unordered data type, so that's the reason if you try to use the slicing, dicing, and indexing format, which is not at all possible. Okay. Now what I can do, if I try to access the data, or if I try to hold the data, if I try to hold the data, try to hold the list and set and dictionary. So this is the three data types. If I try to hold inside of the set, what happens, we'll see. So set, it may having the integer, right? For example, I just want to be hold some kind of list as a element of the set, which is not at all possible. Okay, are you following my point? If I'm trying to be holding some list data as a element of the set, which is not possible, because of which is unhashable data type. Unhashable in the sense something we can modify, that we can call it say unhashable. Okay, and same way, if I try to tuple also, we will try what happen, we'll see. Inside of the curly braces, that means inside of the set, I try to hold the set again, which is also not possible. I can try with indexing, dicing, dictionary. I can try to hold the dictionary as element of the set, which is not possible. So here, what I observe, if I try to hold the list, if I try to hold the set, if I try to hold the dictionary as the element of the set, which is not possible. Okay, but now what I can do, instead of the list, if I try to hold the tuple, what happen, we'll see. It can hold. Okay, now instead of the list or tuple, or instead of the list or any other set or dictionary data type, if I try to hold the some string as element of the set, so here we don't have any problem, so we will get output as like set only. Okay, so here the tuple and string we can hold as the element of the set. We cannot hold the set, dictionary, list as the element of the set. Is it clear now? Is it clear now?
Yes.
Okay, now what I can do, I can try to hold these some same data elements. So I hold the 34 two times, and the 34 two times, 91 time, and again 34. So let's try this thing. Actually here I have a data elements are 34, 90, 34, 89, 34, 90 and 2. So here 34 which is repeated 3 times, 90 which is repeated 2 times. By the time, instead of accessing this many times or instead of holding this many times, the set is having the possibility or the set is having the capability. So duplicate elements which is not accessing, which can holding, even you can try to hold the multiple elements with the same data. By the time it can hold, it can accessing only one element. So here 33 or sorry 34 which is holding 3 times by the time of giving the data as a set, but instead of taking the 3 times which is considering as the only one time. Okay, even 90 also, 90 actually we hold 2 times, but it can be considered as the only one time. So that's what I'm trying to tell you. So duplicate elements can be removed. Duplicates can remove. Okay, duplicates can remove. I hope you clear. I hope you clear. If not, let me know. Guys, can you please let me know?
Yes, it is clear.
Okay. Okay, now, so we have some kind of properties for the set, or we have some kind of functions are there in a set. Let's discuss those particular functions. What are the operations we can do on the set? So when we have the two sets, what kind of operations we can do? Let's see. Usually in a sets we can do union, intersections. Okay, we can do unions, we can do intersection, right? For doing the union, we have the OR operator in Python programming language. For the same thing, when I'm using the OR operator, internally we have a method is there, which is underscore underscore OR underscore underscore of B. So same thing, what you can do, we have some manipulation method is there, and which is the directly union only. So we can directly use the A union of B, or else A or B, or A dot underscore underscore or underscore underscore of B. These three things are giving the same results. So this is the operations: union, intersection, symmetric difference, difference, those kind of operations we can do. And I want to access the common elements. If I try to access the common elements, then we can use the intersection. So intersection in the sense common elements from the A and B. So here the A and B, which we have the common elements 12 and 34, so that we are getting the result is 34, 12. Okay, that's cool. Now I can use the minus. When I'm using the A minus B, which means from A and from A and B, the common elements we are removing. A minus B, or else A underscore underscore sub, or else A difference of B. These three are giving the same results, but which is not same as the B minus A. B minus A in the sense we are removing the elements from the B, whatever the elements are common in A and B. Okay, so which means B minus A or B dot underscore underscore sub underscore underscore or A dot B difference of B, sorry, A could be the different here. See, from A, non-common elements we are accessing, and B minus A in the sense from B, non-common elements we are accessing, which is the difference method is doing actually. Oh God, stomach pain. Okay, now symmetric difference. Symmetric difference in the sense, first it will do the A or B, and the result, what we are doing, A intersection of B. So try to understand here, this is the symmetric difference meaning. Union, we are removing the intersection elements. From the union, non-common elements from the A and B, that we are calling it as symmetry difference. So there is no specific, so for that one we have a direct method is there, or direct operator is there, which is the cap operator, A cap of B. So which means it's, we can call it XOR. So by the time of method symmetric difference. Okay, so these are all, these four are same or not? XOR means from union elements we are removing the common elements, intersection elements. Non-common elements, that we are calling it say XOR. Okay, so this kind of operations we can do on the set data type. As of now, this is fine. For example, we have a set, I have a set, I want to clear the all elements in one shot. Of course you can do, you can remove all elements in one shot. A dot clear, when I'm using the A dot clear, you are removing the all elements in one shot. So that's the reason initially we have the 4 elements, but whenever I'm using the clear, we are clearing the all elements from the A. Okay, now we have a method is copy. So B equal to A dot of copy, which means you're copying the elements from the A and you're assigning to the B. So by the time if you modifying the A and it could not affect it for the B, so that is we are calling it a shallow copy. Okay, ఆకలి అవుతుంది నాకు ఆకలి అవుతుంది ఎందుకో ఇవాళ. Okay, same thing we can do for the direct assignment operator. By the time here both are same only, right? The what exactly the difference? The difference is if I try to modify the A or B, it won't be affected for the second one. For example, I just want to be add some new element to my existing B set. So by the time the B only can affect it, A could not affect it at all. But if the same thing if I do for the assignment operator, so even if I do any kind of changes in any one of the variable, the effect can happen for the both. So that's the only difference between the A dot copy or direct assignment operator. Okay, I hope you can clear all elements in one shot, and you can add one element to our existing set. Okay, I want to remove the some specific element. indexing is not at all supported, right? For example, I want to remove the one specific element. Of course, you can do it. For example, I want to remove the 10. Yes, you can do. So same thing, if I do for the discard, if I did the discard operation, so here also we can remove it. Then what is the difference between the remove and discard? So in case of remove, if element is not at, if the element is not found, if element is not found, then it can be an error. Same thing, if I do for the discard, it won't raise an error. Discard of 1000 or 10,000, whatever it is, if element is not found, it won't raise an error. But in case of remove, 100% it can be raise an error. That's the difference between the remove method and discard method. Okay, clear?
Yes.
Yep. Now we have the two sets are there. We try this one. You have the two sets are there. I want to be updating the A with B elements as well. So the elements in A and B both we can combine, and we are holding the same data, and that means the union of A and B, the result we are holding into the A itself. That's the reason A is modified but B is not modifying. So we are just updating only A with elements of previous and present elements of the B. Okay, so the A which is containing the both A elements and B elements in A, when I do the A dot update, same thing, it can be supported for the intersection and update. So when I did the intersection update, A intersection update of B, which means that, so what are the elements are common is there in A and B, those common elements we are holding into the same variable A. Okay, same thing we can apply for the difference and update. So first it will difference of A and B, the result of the A minus B that we are holding into the A itself, that we are calling it say difference update. And the symmetric difference update also can do the same thing. The same thing in the sense, first it will do the symmetric of A and B. So that particular result we are holding into the A variable. Okay, so previously the A variable data is different, and present the A data is different. Okay, clear? For example, you have some elements are there. I want to remove the elements from right to left, or I want to be access the element as well as I want to remove it. By the time we can use the pop. When I'm using the pop, whatever you removed from the A, the element it can be written as well as it can be removed. So here the first element is the 8, so that which is removing the first element when I'm using the A dot pop. So if I remove the 8, then we have only 3 elements. If the same thing, if you repeat it, so the second element, it could be the 34. 34 also can be removed. Okay, here the first element is 8. For second pop, the first element is 34, so that which is removing. After you remove the 34, then we have only 2 elements. This is exactly the pop is doing over here. Okay, is it clear? For example, I want to know the what are the methods are there in set, then simply we can use the dir of set. See, okay, as of now we understood the update, union, symmetric difference, update, symmetry difference, remove, pop, So this superset, subset, and is disjoint we were not yet discussed, but we discussed the intersection update, intersection, discord, discord update, difference update, and difference, copy, clear, add. These all methods we seen. Only these three methods we were not yet seen. Let's look those three methods now. For example, we have the two methods are there. We have the two sets are there. So here A and B, there are some common elements are there. So when I have the common elements in A and B, if I have the common elements in A and B, is disjoint can be returns the false. So is disjoint is the method. It can be returns the true when I don't have any kind of common elements. So here 34 12 is not there. If I try to is disjoint, then there is no common elements in A and B, so that it was returns the true. If is there any one single element as the common element for the A and B, by the time is disjoint can be returns the false. Okay. Now, so here superset and subset is subset, A subset of B. Here subset means A is subset means the elements what we have in A, that all elements it must be there in B. That situation, A can be the subset and B can be the superset. Okay. If and only if we have all elements A and the elements are there in B, then A could be the subset, B could be the superset. But unfortunately, there is some common elements, but not all, so that we can try with other example. Here I have the 12 and 34. The 12 and 34 which is there in B also. By the time A is the subset, B is the superset. Okay. But if I do the B is a superset, 100% both are returned the true. Okay. So these are the operations we can apply on the set data type. I hope so you guys are followed my point, and if you're not at all followed, please let me know. I will try to answer your questions. This particular class notebook I would like to upload into our Canvas playlist. So this one you can able to access, but when you shared your mail ID to us. So guys, this is for today's class. I hope so. For the next class, we'll discuss about set data type. And if I complete the, for next class, we are going to discussing about dictionary data type. If I complete the dictionary data type, so which means that we were done the all data types from the Python programming language. Okay, fair enough. And we'll catch up in the next class, guys. Take care. See you. Bye. Powell, I hope so you understood for today's class, and please practice for today's class. And if you have any doubts, please let me know. I will try to answer your questions.
Thank you.
Yeah, fine. Take care. See you.